Hello, good evening everyone. I am Professor Shalini Sahay from EC Department, SIRT Bhopal. Today, in this lecture, I am going to discuss the cascaded T section. Cascaded T section as a transmission line. Now, the circuit model or the lumped constant or the model approach. Normal circuit consists of lumped elements such as R, L, C and devices. The interconnecting links are treated as good conductors, maintaining same potential over the interconnecting links. Effectively, links behaves as short between components and devices. Circuits obeys voltage loop equations and current node equations. This is the circuit which is showing the lumped constants in a circuit. Now the transmission line, here it is the signal source and it is the terminal load. Here we have joined the various T section in cascade to show the transmission line. If the final section is terminated in its characteristic impedance, the input impedance at the first section is Z0. Since each section is terminated by the input impedance of the following section and the last section is terminated by its Z0. All sections are also terminated. Here the characteristic impedance of the T section is given by under root of Z1 into Z2 1 or plus Z1 square by 4. There are n such terminated section where the IS and I are the sending and receiving end currents. Here, gamma as the propagation constant for the one section is denoted by IS upon IR, or e to the power of gamma is 1 plus 2 Z1 upon Z2 plus Z0 upon Z2. Here we can denote by gamma and taking the natural log on the other side. A uniform transmission can be viewed as an infinite section symmetrical T networks. Each section will contribute proportionate to its share RLGC per unit length. Thus, lumped methods analysis can be extended to transmission line too. Here, the analysis developed for the lump constants can be extended to distributed elements. Here, we have taken the constant of an incremental length, that is del x, of a lines are indicated as series constant. Here we have taken the series elements, inductor and the resistance, and the shunt components where we have taken as the gamma plus j omega c, or it is the admittance. Thus, one T section representing an incremental length del x of the line which has a series impedance, ohms, and shunt impedance. The characteristic impedance of all the incremental sections are alike, and since the sections are alike, the characteristic impedance of any small section is that of line as a whole. So we can say that equation 1 will give the characteristics of the line with distributed constants for one section, and it is given by the following equation. Here we have taken the characteristic impedance for the transmission line where del x2 approaches 0 in the limit time value, and Z0 for the line of the distributed constant is obtained by the function as under root Z upon Y. Z and Y are in terms unit length of the line, and the ratio Z upon Y is the independent of the length unit chosen. Here we have denoted the propagation constant. Under Z0 termination, we have taken the propagation constant I1 upon I2 is equals to e to the power of gamma, and where we have taken the propagation constant in terms of the impedances. Here we have calculated the gamma for the, and we have applied for the incremental length, and we have calculated the gamma. Series expansion is done with the help of e to the power of gamma del x, and equating the expansions and cancellation unit terms and then divide by del x. We have got this equation. Here, the characteristic impedance Z0 is equal to under root Z upon Y ohms, and the propagation constant is given by this relation. Characteristics of surge impedance. Since there is no energy is coming back to the source, there is no reactive effect. Consequently, the impedance of the line is pure resistance. This inherent line impedance is called the characteristic impedance or surge impedance of the line, where the characteristic impedance is determined by the inductance and capacitance per unit length, and these are the dimension of the line which decides whether the line impedance, the closer the two conductors of the line, the greater will be the diameter, and higher will be the capacitance, and lower will be the inductance. A line with large conductors closely spaced will have low impedance, and a line with small conductors and widely spaced will have relative large impedance. The characteristic impedance of typical line ranges from a low about 50 ohms, and that tends to be 600 ohms for an open transmission line. Here the characteristic impedance has been taken, and it depends upon the value of L and C. Here we have chosen the characteristic impedance. We have calculated the values of characteristic impedance, and finally the transmission line is a critical link in any communication system, and it behaves as a connecting link between the receiver and transmitter. RLC are the components. It behaves like a resonant circuit. It is a reactance impedance, and it is an impedance transformer. Thank you.